So now we're doing Kaggle's Intermediate Machine Learning course. And this is the introduction. We're going to review what we need for this course. Let's do it. All right. So here's the introduction. Welcome to Kaggle's Intermediate Machine Learning course. Yay! If we have some background in machine learning and we'd like to learn how to quickly improve the quality of our models, we do have some. We're in the right place. Great. So in this course, we will accelerate our machine learning expertise by learning how to tackle data types often found in real-world data sets, like missing values and categorical variables. Yeah, the missing variables, actually both of these were problems in the last one. Design pipelines to improve the quality of our machine learning code, whatever that means. We're going to use advanced techniques for model validation, so cross-validation. We're also going to build state-of-the-art models that are widely used to win Kaggle competitions like XGBoost. And we're going to avoid common and important data science mistakes like leakage. All right. So along the way, we're going to apply our knowledge by completing a hands-on exercise with real-world data for each new topic, just like we've been doing. The hands-on exercises use data from the housing prices competition for Kaggle Learn users, where we'll use 79 different explanatory variables, such as type of roof, number of bedrooms, and number of bathrooms, to name a few. Pardon me. To predict home prices. Whatever. All right. So we'll measure our progress by submitting predictions to this competition and watching our position rise on the leaderboard. Okay. So here's the prereqs. We're ready for this course if we've built a machine learning model before. We have. And we're familiar with topics, such as model validation, underfitting and overfitting, and random forest. Yes, we are familiar with all of those. So if we're completely new to machine learning, we can check out the thing we already made a video about. And now it's our turn. We're going to continue. We're going to continue to the first exercise to learn how to submit predictions to a Kaggle competition and determine what we might need to review before getting started. You know what? We didn't learn anything on that one, and we got to go a little bit faster on this. So you know what? I think it's time to double up the lesson and the exercises on these. So that's what we're going to do. That means we can skip this line while we're at it. Give me a second. All right. So as a warm-up, we'll review some machine learning fundamentals and submit our initial results to a Kaggle competition. Okay. Here's the setup. The questions below will give us feedback on our work. We're going to run the following cell to set up the feedback system. Okay. So run this thing. It's a little bit different than usual. We've got this import OS. I plugged this whole thing into Gemini to tell me what was up. This is like the operating system. It's like to make a virtual operating system or something. I don't know. Or no, this is to access operating systems. So if not os.path exists this thing. So if this file path doesn't exist on the operating system, we're going to make it. But we're going to take this one right here and we're going to put it right here. So it's a little bit easier to get. So instead of having to go from home data for ML course, train CSV, we just put it straight up in here, right? Just like, so I guess just going up one level, whatever. And the same thing for the test as well. And then we've got the learn tools.import or whatever binder. And this is the stuff we've seen before. And then the setup is complete. All right. So let's get to it. We will work with data from the housing prices competition for Kaggle Learn users. Is there an echo in here? A long echo, whatever. To predict home prices in Iowa using 79 explanatory variables describing almost every aspect of the homes. A little copy paste right there. We're going to run the next code cell without changes to load the training and validation features in xtrain and xvalid. I don't even remember what we were calling it in the last one. Come on, man. Stuff is so annoying. All right, is that good? Did it get back to normal? No. Oh, God, this pisses me off so much. I don't even remember how to fix it. Maybe it's unfixable on this one. Whatever. All right. Yeah, there's that picture. We're going to run the next code cell without changes to load the training and validation feature in xtrain and xvalid, along with the prediction targets in ytrain and yvalid. The test features are loaded in xtest. If we need to review this stuff, we can go and watch the tutorial that we already seen. Man. Whatever. And then some more stuff. It doesn't really matter. All right. So basically, let's run this thing right here, and it's going to be the rest of the what? Bro. Do we have to run this? Okay, let's run this. We did run that. Now we run this. Okay, whatever. All right. So basically, it's just going over the normal stuff. Importing pandas, importing train test split, and then reading the data, obtaining the target predictors. So just making the Y series and the X data frame, and then doing train test split and assigning all these to whatever comes out of this. But this is, I don't know what that's about, but whatever. Oh, no. Instead of doing half and half, it looks like we're training 80% and testing with 20%. That's pretty cool, actually. All right. So that's cool. We're going to use the next cell to print the first several rows of the data. It's a nice way to get an overview of the data we will use in our price prediction model. Yeah, so it's just xtrain.head. Boom. First 5. Boom. Just like we have seen before. The next code cell defines 5 different random forest models. We're going to run this code cell without any changes, okay? So let's run this, and we can see we've got 5 different models going on here after we import the random forest regressor. The first one has this, all 5 of them have these in estimators, which I don't remember what we usually put in here because, you know, how am I supposed to? But it's definitely looking different from usual. So we've got in estimators is 50 instead of, what was it, like max? Wasn't it like max something else? It wasn't max sample spit. Was it max depth? I don't even remember. But whatever. So we've got in estimators equals 50. We've got estimators equals 100. We got 100 here, but we also have criterion absolute error, whatever that means. We've got 200 here with min sample split 20. I don't know what that means. And then we've got the estimators 100, max depth 7, and then all of them have random state 0. And then we've got this models variable that's putting all 5 of the models in this list right here. All right, so we've got that going on. So to select the best model out of the 5, we define a function score model below. All right, pardon me. This function returns the mean absolute error from the validation set. We're going to recall that the best model will obtain the lowest may. All right. To review this, we know about that. So we're going to run the code cell without change right here. So let's run this and go over it. So now we're importing the mean absolute error function, and we're defining this function right here, score model. We've got the model here, and then we're also hard coding these 4 parameters in there. So we've got the X train, the X valid, the Y train, the Y valid right there. Then we're fitting what the train, the XT, and the YT to the model, and then we're doing the predictions right here, model.predict with the X valid, with the Y valid. Okay. And then also, with the X valid, and then we're going to return the mean absolute error, Y valid, and then the predictions as the second argument. All right. So now we got this for loop here for I in range 0 to the length of the models. And we can see the length of the models is 5 right here. So it's going to go from 0 to the end. And what we're going to do here is we're going to, for each one of those up there, we're going to make this, we're going to assign this may to be score model, which is this thing right here with models at I. So first it's 0, 1, 2, 3, and then 4. And then we're going to print model with the I plus 1 so that it gives us model 1 instead of model 0. And then we're going to say may with the actual may. So we've got models with the I plus 1 and then the may right here. And we can see the smallest one is going to be, we've got 24, 23.7, 23.5, 23.9, and 23.7 again. So 23.5 is going to be the best one. We got model 3 right there. All right. And wouldn't you know it, now we're on to step 1. All right. Evaluate several models right here. I'm running out of steam, but whatever. No big deal. We're going to use the above results to fill in the line below. Which model is the best model? Our answer should be one of these right here. So we're going to have, we're just going to point it to one of these models right here. One of these models right here. All right. And we already know it's model 3, so let's just grab this one while we're at it. All right. So let's toss this in here. Because, you know, we could do the a for loop or do a min of all of them, but believe it or not, if we come over here to the solutions, let's check this. It's correct. If we go over here to the solutions, they didn't bother with it either. All right. So why should we? All right. So step 2, generate test predictions. Great. So we know how to evaluate what makes an accurate model. Now it's time to go through the modeling process and make predictions. In the line below, we're going to create a random forest model with the variable name myModel. All right. So myModel will just use the best model. All right. Let's toss this in here. And then let's check it. And look, it's correct. How did I know? All right. Let's check the solution. And there it is. All right. I think the first time I did this, I tried to put a bunch of code in here, but turns out they're not looking for us to reinvent the wheel by any stretch. All right. So we're going to run the next code without any changes. This stuff right here. And then the code fits the model to the training and validation data, and then generates test predictions that are saved to a CSV file. These test predictions can be submitted directly to the competition. Oh, woo. All right, so we're fitting it right here. We're going to fit all of X and all of Y to myModel being the best model. All right, now we're doing predictions, and it's going to be myModel.predict, and we're going to put X test in there. I mean, didn't they say we aren't supposed to make predictions using model data? I don't remember. Anyway, whatever. And then we're going to save the predictions in a format using used for competition. So this is just stuff to turn it into a CSV, right? So now we've got the same submit our results from the last video. So when we do that, what we're going to do is save the version to start off with. Save it, all right? And we'll fast forward until this is done. Hold on. Whew, that was a while, actually. All right, so we already did that one. So we did that, and now let's come over to show versions, click the ellipsis, submit to competition, blah, 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 submit it. And here we go. Pending now. And we see this is nowhere near as good as the one we did in the last video. So it is what it is, all right? This one's 3,000 change off. So whatever. Anyway, let's go back to here. And let's finish this thing up. At the bottom. All right, so there's that. We're going to keep going. We've made our first model, but how can we quickly make it better? Wouldn't that be nice to know? So we're going to learn how to improve our competition results by incorporating columns with missing values in the next one. All right. So now we're on to missing values, and we'll see you next time.